Hi guys, welcome again. Here's your talkative Sai Krishna, and in today's presentation we are going to learn an overview the commitment of US government to electrify its ground fleet. So it's a very nice topic. Let's dive deep into it. Before that, I want to let you know who I am. Well, my name is Sai Krishna. I am presently a student who is studying data science at IARE. So, what are the objectives of today's presentation? There are not many, just two objectives. First, we will understand why there a need arise for electrification. Then, what were the recent developments for these efforts? Recently, you have been informed or heard that all the governments of the world are pushing green initiatives, but you must know the reason why, right? But and also why now? Why it didn't happen at 2010 or whatever, but why now? So in the first objective, we are going to question the why now and why there is a need. Next, we will understand what developments were made or what efforts were taken to achieve this low fee goal. So let's start with our first objective, why there is a need for electrification. The US Army has been pursuing efforts to achieve better fuel economy in its ground vehicles to reduce the overall fuel-related logistic burden as well as enable cost savings. In military applications, depending on the destination to which fuel needs to be carried and the way it is carried, that is by ground, air, ship, etc., the cost per gallon of fuel can be in the range of 1,000 US dollars in certain cases. Now you might ask, what is $1,000? It is essentially 70,000 rupees. If we assume 70 rupees as $1, and a gallon is more than 1 liter. So for transporting more than 1 liter of fuel and less than 2 liters of fuel, it takes nearly 70,000 rupees. This is inefficiency at its premium, if you ask me. So why this? This is a large expense, and there is always the motivation to improve fuel economy in the military. So you think 70,000 rupees is being wasted for just transporting fuel which is greater than 1 liter. If the efficiency was good, then the amount which is remaining can be used to modernize or to give welfare to the soldiers, right? So military is always finding ways to improve their fuel efficiency. Among various activities to achieve the goal of fuel economy improvement, vehicle electrification is considered to be an important one and includes the introduction of hybrid electric vehicles in the military. In addition, the army also needs high voltage, high power electrical devices for non-vehicular applications, but not limited to certain types of arms that can be electrified. Okay, let's move on. Now, some promising technologies were pursued within US Army, which was RECEOM, TARDC, GVPMD. What are they? RDECOM refers to Research Development and Engineering Command Tank Automotive Research Development and Engineering Center. Next, ground GVPMD refers to Ground Vehicle Power and Mobility Department. So these two organizations are working tirelessly to make US ground fleet electrified and to develop certain technologies which make it possible. And it has been being done for past several years. So what technologies they were able to come up with? The first is hybrid electric configurable movable integration test bed. essentially the prototype for all the technologies that are being developed by these two organizations. DC-DC converters, silicon carbide based power electronics, integrated starter generators. We are going to learn about them in depth in coming slides. Just for now, names are enough. So these four technologies are being pursued by these two organizations within the US Army, and these provide great promises for electrifying the US Army ground fleet. By this slide, I'm quite sure that we have understood why there is a need for electrification, as purely it is of economics, not of concerns over global warming, but because of economy, capital that is spent for logistics. Now, next, important differences between commercial and military applications of vehicles. But you might have a question, why you have to spend 70,000 rupees to transport, well, say, more than 1 liter of fuel? So we are going to know why in this slide. The cost of fuel can be very high for military applications because the fuel often has to be carried to the field of operation. When a temporary military base is established in a zone of operation, it can be very useful to quickly establish electrical power, both utility level and other voltages. So why? For security reasons, it may be imperative to carry the fuel instead of depending on other sources. Even if fuel may sometimes be available in a combat region, it is more than unlikely to be in no unknown and or in hostile regions. Therefore, the military cannot rely on the quality of fuel obtained from such sources, which could potentially compromise the operation of the vehicle. In a zone of operation, besides military vehicles and armaments, the military must normally establish temporary living and office type facilities which need utility level voltage due to stationary loads. So, simply put, there can be a sabotage that may occur when you locally source the fuel, and the quality of fuel may alter the performance of the vehicles. So, these main reasons make army to transport fuel from their home country or from bases where they can trust. That is the reason the cost of transport is so high. Military equipment is subjected to harsh environment in terms of temperature and also noise and vibration. Failure of equipment, unlike in most commercial applications, can in many situations be the difference between life and death. You know this stuff, right? So if you use a low quality fuel which is obtained from a source locally sourced, the quality of fuel is bad, due to which the performance of vehicles is greatly reduced, and by chance, if if the vehicle stop working while in a tense situation, it may result uncalled deaths. So as army always equates life more than money, they spend 70,000 rupees to transport more than 1 liter of fuel to save one life or to save many lives. So how can they reduce it? Simple, take the fuel out of the equation. Now, we are going to just have an insight over what are these projects which are being developed by the two mentioned organizations, and what are their progress and how they are doing overall. So the first is Hermit project, which is a test bed for all new innovative technologies. The objective of Hermit project was to study the performance, component, interaction, system architecture with different topologies and grounding and shielding, and to test advanced components such as CIC power electronics, based traction motors, inverters, CIC based DC-DC converters, motors and generators, and cooling systems. So, the propulsion system consists of an engine driven generator and energy storage battery pack. Both the generator and the battery provide power to traction motors and other auxiliary systems to power conversion devices, replicating a field vehicle environment. As I have said, it is a test bed. So, what are the progress? Hermit provides the capability to replicate the behavior of a vehicle by using dynamometers to simulate vehicle mobility load on the system. While testing the hermit bed, the successful completion of the converter test at 100 degrees Celsius coolant temperature was the most significant accomplishment pertaining to the needs of the army application. So, what the last uh, bullet point is referring that while testing the hermit test bed with an advanced technology, it was able to cool the advanced technology not specified to its optimum temperature. Even the outside temperature was 100 degrees Celsius. I know 100 degrees Celsius is too much, but over the time, when you use it continuously, this temperature can be achieved in some battle scenarios. So they have tested the Hermit test subject. The test bed is really effective in testing innovative technology. So it's one of the accomplishment of the Hermit project. In a real experiment, it was connected to a DC dynamometer, which was used to replicate the loads encountered by the actual vehicle on US Army's Aberdeen Proving Ground. Okay, next. So we have completed our insight with the Hermit project. Let's move on to next project, which is SiC based power electronics. You may wonder what is SiC? It's silicon carbon based. Okay, now, managing temperature or the ability to survive high temperature is a priority in power electronics application. With that perspective, the military has invested significantly in research related to WBG semiconductors, particularly in SiC. I'll ask you a question. When your phone gets hot, and due to which its performance reduced, and technically it is known as throttling. Now, if the phone was made to work in its optimum temperature by using an external cooler, obviously the power which will be consumed for the whole system will increase the efficiency decrease, but the object will be served. But what if we develop such electronics which are able to work at optimum temperature even when there is a shear load? Well, here comes SiC. SiC are materials through which semiconductors are made. Now, these semiconductors have very thin film due to which the collision between electrons while transferring electricity is minimal, which results in less heat produced. SiC is very important for to make electrification possible in a battle scenario. Now, the use of WBG semiconductor materials for power electronics contribute to minimizing losses and reducing thermal management needs and maintaining high efficiency. As I have said, if the electronics are capable to keep themselves cool without using an external aid, then the efficiency of the overall system will definitely increase. So these two departments of US Army are working on developing SiC based electronics so that they can increase the overall efficiency of their electric vehicles. Next, integrated starter generator. Let's see. The objective of dual voltage ISG project was to demonstrate a system comprising a generator with two outputs plus an associated conversion and regulation electronics as a feasible alternative to existing systems. The ultimate goal of this work is to confirm that a dual voltage ISG is suitable for use on tactical and combat wheeled vehicles. It should be noted that the ISG concept is not only applicable to hybrid electric vehicles, but can also be used beneficially in legacy vehicles in terms of meeting high power demand and more compact packaging. Essentially, what it wants to convey is dual voltage. Now, this is a very interesting term. Instead of generating voltage by a single source, we can divide it between two sources in order to increase its efficiency, by which the thermal throttling will be reduced and more range or more useful electricity can be utilized. This same method is also used while fast charging certain mobiles. Certain mobiles, which are manufactured by BBQ Electronics Group, contain dual battery cells inside their phones. And due to this, the battery capacity is divided between these two cells and they get charged faster. Moreover, the efficiency of this is really higher as there is 12 voltage. So they are trying to implement this in a large scale in order to increase their efficiency. Now we have by this slide we have completed the technical developments which happened in this initiative. So what are political developments which happened in this initiative? So let's see. Deputy Defense Secretary Caitlin Hicks said fleets of electric vehicles ready to shoulder the military's workload and slash greenhouse gas emissions over the coming decade. That's what the Pentagon is hoping it can pull off as part of President Joe Biden's effort to combat climate change on 9th November 2021 at Wayne State University in Michigan. So this lady is Deputy Defense Secretary, and her name is Kathleen Hicks. On November 29, 2021, she quoted the above statement, which proves that the government of US is very serious for this initiative. She also added, electric vehicles are quiet. They have a low heat signature and incredible torque. And because they tend to be low maintenance, with fewer moving parts, they have the potential to reduce logistics requirement. As I have said, US Army uses tremendous amount for its logistics needs. But if they electrify, they can save so much that they can divert that capital to other useful requirements. In October 2020, the US Army released a white paper that stated that in 10 years, some of our brigade combat teams, essentially integrated battle teams, which include Marine Corps, Army, Air Force, Navy, will be all electric. That's a generational change. It's significant, and we are going to do it, and we are going to need the industry's help. There's plenty of people who say we can't do it. So essentially, US Army was mocking that we will do it, and there are more people to disbelieve on us. This also states that US Army is very serious over this initiative. Summary. Summary. Now, why there is a need for electrification? And so what? Why there is a need for electrification? We have learned about that. Next, recent developments for this effort. We have also covered that, both technical aspects and political aspects. Now, these provides sufficient evidence that US Army is very serious over electrification of its ground fleet. Now, by this statement, I'm going to end this presentation. Thank you for listening with me and learning of the initiative that has been pushed by the US Army. It's a really good initiative which reduces its capital expenditure on logistics, but also provides a great support for a green initiative that is taken by the world. I hope all other armies will also follow the same and we can reduce the greenhouse emissions effectively. So let's meet up again in another presentation. Till then, have a nice life. Sayonara.